Hi class, so sorry that I cannot be there. Wish I could, but I am home with a sick child. I just wanted to quickly kind of refresh and review electron configuration, orbital diagrams, valence electrons, those kind of concepts here. So if you go to OneNote and go to the content library, I put in a new page called just periodic table. So it's just this empty periodic table, and we're just going to take some notes on that and everything. So if you can just follow along, copy that to your OneNote, and we'll start from there. So wanted to spend a little bit of time first off reviewing the different blocks. So we have, remember, this is your S block. So it's all of these, and it makes sense that it is 2 columns wide, because remember the S can hold a maximum of 2 electrons. All right, so we're going to go through all the different S, P, D, and F. We're going to go through how many orbitals there are and how many valence, sorry, not how many valence electrons, just how many electrons maximum that it can hold. So remember, this is the S. It can hold 2 electrons. All right, so how many orbitals it was? So if you think back to the gizmo, that's just how many boxes there were. So remember, all S, whether it was 1S or 2S, always just had 1 box. And that box, like I just said, represents an orbital. So S's have 1 orbital. Remember, once we got to the P's, like a 2P or 3P, there were 1, 2, 3 boxes. Remember, each box, each orbital could hold 2 electrons. So that's how we get to a P having 1, 2, 3, 4, 5, 6 electrons. All right, so let's go ahead and mark our P section on the periodic table. So I'm going to move. And I know we've done this before, but we got to keep practicing identifying those blocks. All right, so that's our P. The next one is our D, so that is down below here, your transition metal chunk. D. And as you can see, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns wide. So it holds 10 electrons. There are 5 orbitals. So hopefully you notice this pattern, right? You're going up by 4, so you can guess that the F orbital can hold 14 electrons, and there are 7 orbitals within a F. And our F's are down here. So there are our different blocks. So remember, we can go ahead also now and label that this is your 1S, 2S, 3S, 4S, 5S, 6S, and 7S. And then remember, P's start at 2, so that's 2P, 3P, sorry it gets messy here, 4P, 5P, 6P. D's start at 3, so 3D, 4D, 5D, 6D, and then your F's start at 4, so 4F and 5F. So you notice S's all start at 1, P's start at 2, D's start at 3, and F's start at 4. One thing also that I wanted to talk about is when you're writing an electron configurations. For example, if I write 1s2, this number, remember up here, is telling you the energy level. And so remember, all electrons, we're always going to start off with this 1s. Electrons are going to go in the lowest energy level possible, and then you're going to fill the orbitals from there. And then this s is telling you the subshell, and also like the shape, right? Whether it's a sphere or dumbbell or something. And this is telling you the number of electrons in that certain subshell. So if I was to ask you how many electrons are in the first energy level, there can be only a 1s. So let's do another little chart. So in the first energy level, what orbitals there are? There's just an s, so how many electrons could just be in the first energy level? 2. Right? If we look then at the second energy level, I see that there's a 2s and a 2p. There's not a 2d or a 2f. So in the second energy level, there's just an s and a p. So remember, s can hold 2, p's can hold 6. So the total number of electrons that could be in the second energy level would be 8. Moving on from there, if we looked at the third energy level, there's an S, a P, and a D. No F, because F start at 4. So S, P, D. So that's 2 right there, 6 there, and 10 there. So that would total up to 18. If we looked at the fourth energy level now, there's an S, a P, a D, and we see now there's an F. So S, P, D, and F. So that's 2 there, 6 there, 10 there, and 14 there. If you add that up, that's going to give you 32 electrons.